Hello Hornets, welcome and thank you for joining me today. Today we are looking at analyzing rational functions. Specifically, I have a function on the whiteboard here, f of x equals x squared minus 6x plus 12 over x minus 4. And I'm using this as just a review to help people who are still struggling with analyzing their functions. So the first thing you want to try to do is find your x-intercepts. To find the x-intercepts, you look at the numerator, and we try to factor if it's able. You'll notice x squared minus 6x plus 12 is not factorable. And this requires me to therefore use the quadratic formula. The problem is, when I use the quadratic formula, I end up getting 1 over, 6 over 2 plus or minus the square root. And you'll notice that I end up having 36, and I'm subtracting 48. This is giving me an imaginary number. And because I get an imaginary number for my x-intercepts, I know that there are no x-intercepts for this graph. The second step that I'm going to look at is the denominator, and I'm going to identify that the denominator has an x minus 4 in it. That means that there is an asymptote on the graph of this f of x at x equals 4. And I'm going to want to list that down. So we say there are no x-intercepts, and then f of x has a vertical asymptote at x equals 4. Now we can see that the order of this factor in the denominator is odd, so we know that f of x is moving in opposite directions on opposite sides of the pole of this order, or of this asymptote because of the order. So f of x is moving in opposite directions on opposite sides of the asymptote. Excuse me, and this is because the order is odd. And remember, we call the degree in the denominator an order. We call the degree or the power in the numerator a degree. All right, so we now have that there are no x-intercepts. We have our vertical asymptote. Let's find our y-intercept, shall we? If I let x equal 0, you'll notice I get 12 over negative 4. So f of x has a y-intercept of negative 3. Once again, it is a y value. This is when x is equal to 0. The next thing I'm going to want to find is my slant asymptote. And I know there's a slant asymptote because the degree in the numerator is higher than the degree in the denominator. And I have two choices. I can either use synthetic division or I can use long division. Now, we've done long division in the past. Let's just look at it. This is where we take our denominator and we put a divisor, we put it outside, our dividend goes inside, and then we divide. So we take the variable's highest power inside over the highest power outside, we reduce, we distribute. X squared minus 4x, we subtract, and we get negative 2x plus 12. We repeat the process, negative 2x divided by x, we get negative 2. Negative 2 goes up top. That's going to give me negative 2x plus 8. We subtract, we get a negative 4. So this is my remainder. Now the quotient right here is the slant asymptote. Okay, so f of x has a slant asymptote at y equals x minus 2. The next step is for us to figure out our relative maximums, relative minimums. This is going to be the quotient rule. So I'm going to be working with the quotient rule. Low d high less high d low, square the bottom, and away I go. And so my f prime of x is going to end up being, again, just do it slowly, 2x minus 6 times x minus 4 to the first, minus, and I have a 1 times x squared minus 6x plus 12. And it's all over x minus 4, the quantity squared. Now, when I simplify this, I end up getting x squared minus 8x plus 12 over x minus 4, the quantity squared. And this factors. This is where I'm going to get the values, or at least two of the values, or my critical values, which will be used on the sign chart. So I have x minus 2, x minus 6, over x minus 4, the quantity squared. So I have a negative 2 and a 2. And we have a positive 2 and a positive 6. So we've got our asymptotes. Negative 2, positive 2. We have positive 2. We have, whoops, hang on a minute, I've made an error there. That should just be a 4. Sorry about that, guys. So we have 4 is our asymptote, 2 is our first critical value, 6 is our second. We then have x minus 2 and x minus 6 going up. We don't need the x minus 4, it's got an even power. So when I plug in an 8, I get a positive. And then I get, let's put in a 5, we get a positive. 3, we get a positive, but a 1 is a negative. Putting in an 8 gives me a positive, but a 5 is a negative. 3 is a negative, 1 is a negative. Our goal is to find the product for f prime. We get a positive to a negative, negative to a positive. Remember, this is my asymptote. That tells me that there is a relative maximum at x equals 2, and there is a relative minimum at x equals 6. And then we put in f of x is increasing from negative infinity to 2 with a bracket, and bracket 6 to positive infinity. F of x is decreasing from bracket 2 to parenthesis 4, parenthesis 4 to bracket 6. And it's a matter of just writing that down, and then we'll have to go to our second derivative, and we will have to use this piece right here. And when we're doing our second derivative, f double prime of x, once again, we want to go very slowly. Notice the denominator is going to be x minus 4, the quantity to the fourth. I'm going to now just do my foiling and my derivative, excuse me. So I have 2x minus 8. And then I have this x minus 4, the quantity squared, minus. Then I have 2. I have x minus 4, the quantity to the third power, first power. And then I am multiplying by that entire piece. Where is it? X squared minus 8x plus 12. And I'm going to start by factoring out the x minus 4. That's going to give me 2x minus 8, x minus 4, 2 times x squared minus 8x plus 12. And then we're going to divide. You notice I've already taken out the x minus 4, so it's x minus 4, the quantity cubed. And now I'm going to FOIL and simplify. When I do, I end up getting 8 over x minus 4, the quantity cubed. So I have a 4, right smack dab in the middle, and we have 1 over x minus 4. The 8 is not required, it is a positive and does not change. This would be positive to the left, but negative to the right. And so now I can see that the fact that we have no points of inflection, and we have concave down and concave up. And this is what we're going to want to make sure that we now list. So I'm going to list all of this information down before I attempt to draw my curve. And you'll notice here it is. So I have my relative maximum, my relative minimum. I have my increasing interval and my decreasing interval. Notice the brackets are at the extrema. Brackets at the extrema and a parenthesis at the asymptotes, or moving toward the infinities. There is no point of inflection. F of x is concave down, and notice we have parenthesis at both ends. Concavity always uses parenthesis at both ends. Then we have f of x is concave up on 4 to infinity, and then I just have my note about the order. F of x moves in opposite directions on opposite sides of the asymptote due to the odd order of the x minus 4. And we now go to our graphing. So we'll start by putting in our horizontal asymptote, vertical asymptote, our y-intercept, and then we have our maximum at 2, our minimum at 6. I plug them in to find the corresponding y values, and then I draw my curve. And that gives me my analysis. I hope this has helped. Please click like if you found this to be useful. If you have constructive criticism, please feel free to offer it. I am always looking to improve. Thank you very much, Hornets. I hope this has helped. Please be safe and take care. Stay positive. Remember, optimism is a choice, okay? Just like being mean is a choice. We have the choice to be mean to each other or not. I hope you will take the better road and you will be kind to each other. Thank you very much. Cheers.